Welcome to today's webinar. My name is Tobias Flitsch, Director of Product Management at Nebula, and with me is Aaron Patton, our Principal Solution Architect. Today we will discover the strength of Nebula's smart infrastructure when it comes to infrastructure automation, specifically automation of on-premises infrastructure through the cloud. Now there's obvious benefits when it comes to infrastructure automation. First, that of reduced risk. When you look at traditional infrastructure provisioning, that involves repetitive manual tasks that start with sizing infrastructure, provisioning resources like the operating system, forming clusters, and then creating LUNs. And after that, it's about monitoring and managing availability and performance.
Right, that's not always the best way to do it, right? I mean, although this works and it may be effective, it's inefficient and is often error-prone, right? Some studies suggest that a person makes 3 to 6 errors per hour, and while these errors are often self-corrected, they require troubleshooting and effectively delay the rollout of new services, or even worse, they're not corrected and they open hidden security vulnerabilities in the infrastructure, which becomes kind of a ticking time bomb, right?
Right. And the next one seems obvious, and that of reduced labor and infrastructure cost. And just to clarify, this is not about reducing headcount, because you obviously need to invest in the right people to do automation, right? This is more about not wasting these resources, these existing resources, and shifting them to value generating tasks instead of doing this assembly style type of operations.
Right. I mean, you think how long it takes for a human to type in a command or click on the right buttons without errors, and how they comply with naming conventions and rules compared to automation routines. It's error-prone at best, right? So at the same time, it's about infrastructure resources, right? If infrastructure is configured and set up correctly, you get better uptime, better utilization of infrastructure, and more bang for the buck.
Right. Now, another one is better decision-making. Now, this is often overlooked. Often when we think about and talk about automation, right, it's all about provisioning workflows, setting up new infrastructure services or making changes to these infrastructure services. But there's significant benefits when it comes to infrastructure monitoring and automation. That is, creating inventories and centralized information about health and utilization of infrastructure. With more accurate information, with real-time information, organizations can make better decisions on their investments and their planning. And then ultimately, with proper automation in place, you can achieve self-service infrastructure orchestration. Now, if I look at infrastructure automation and where it's popular and where I see a lot of resources, tutorials, and examples, it clearly points to the public cloud. Now, is that because, automation in public cloud is just inherently easier?
No, I mean, that's not by mistake, right? Public clouds give you a unified way of looking at compute, storage, network resources, right? Each one of these has got a public, stable API that's maintained by the cloud provider that changes very little over time, right? So you can write your automation runbooks around that, integrate with it, and know that it's going to be supported and it's going to work seamlessly. Now, you contrast that moving over to your own on-premises infrastructure, and you might have, a relative hodgepodge of equipment, different servers, switches, all these other things, each one with their own versions of the API, different sets of capabilities within the API that may change with buying cycles, right? We did Cisco this year, maybe not next year, right? So maintaining that, discovering everything, and keeping it functional it can be super complicated for on-premises infrastructures.
Right. Now, we at Nebula, right, we want to solve this problem. It is our mission to bring, the benefits and the experience of the public cloud to on-prem, from your core data center to the edge for any application, whether it's containerized, whether it's virtualized, or if it's bare metal. We enable IT organizations to deploy, manage, and maintain on-premises enterprise application data at scale, as simply and as rapidly as in the public cloud. Now, before we go into the depths of automation and a specific example, let me quickly talk about Nebula and smart infrastructure. Now, Nebula is a cloud-based software company that delivers a new category of smart infrastructure. Smart infrastructure is all around us. Right? Think smart home technology like Google Nest as an example. What they all have in common is a cloud-based control plane managing IoT endpoints in smart devices. Now, with that approach, users get benefits like easy remote management, automatic software updates in the background, and of course, simple automation. Now, this idea is not new for the data center. In networking, for example, you have Meraki Networks, which is now Cisco, and Mist Systems, now Juniper, who pioneered efforts in cloud management and smart network infrastructure. With that approach, they really solved this problem of managing large amounts of access points and switches scattered across the campus and the data center. Now, smart infrastructure applied to application infrastructure, specifically compute and storage infrastructure, that is what we at Nebula do. With Nebula Smart Infrastructure comes the benefits of a public cloud experience, a public cloud-like operating model for your on-prem application infrastructure. Now, what we've done is we've taken the management stack that would traditionally live with the on-premises infrastructure, and we've moved it into the cloud where Nebula ensures that it's always up to date, that it delivers new capabilities on demand, and customers really have to maintain any of that. Think of this as your Gmail account. It's just there, and you suddenly get new capabilities overnight. This is also where we do anonymous analytics, where you as an individual customer, you can benefit from the collective insights and the experience of other smart infrastructure customers, including proactive issue notifications and predictive issue prevention. Now, what remains on-prem is this lightweight data plane software that is embedded in a PCIe card in your on-prem server. We call it a services processing unit, or SPU in short. This data plane provides the necessary enterprise data services for the application servers. Think the services that you get from your enterprise storage array. The SPU then connects multiple application servers together to form an application cluster for high availability, for scaling performance, and for scaling capacity. And we can have a separate discussion about, all of the data services, the clustering, and, our entire architecture. So I'll leave it at that. The thing to remember is that the management and the control of infrastructure sits in the cloud and is maintained by Nebula, while your private data remains on-prem in your control using this data plane that provides secure, shared, and local enterprise block storage services for your servers. Now, this architectural design allows bringing the public cloud experience on-prem. In the context of automation, you now have this single API in the cloud that allows you to orchestrate all of your on-prem application servers and their data services. And when it comes to automation, there are various different options available. One I consider relevant, but likely something that you won't immediately think of when talking about automation, and that is that of a self-service catalog in a user interface. If you think about a marketplace or a service catalog in a public cloud, there's already a lot of automation that is fused into those services, right? So Aaron, why don't you show really what I'm talking about when I mean a service catalog?
Right. So we're going to take a look at Nebula on here, and we're just going to take a look at a small slice of Nebula on because a larger discussion of that would take too long here. But if we go into Nebula on and then look at this tab here called Npod Templates, these templates are what allow us to build bespoke npods targeted at a specific application use case, right? So let's take a look at like this Kubernetes one here, for instance. This template says, hey, I want a Linux operating system that's Ubuntu 2004. We're going to tag it as Kubernetes, which allows us to do some other smart work on it on the back end. And we're going to provision a boot volume. Here you see that it's 60 gigs in size and that it's kept at this URL. What this allows us to do is to blow a image onto each one of these servers that will then go through a customization process, powered by CloudInit in this case, which gives us a unified substrate to do additional work on top of, right? And we're going to talk about that later in the demo, but this gives us a base to work with, right? Mm-hmm. And you'll notice here that we have the option to provision storage volumes. That's not selected in this particular one, because in some cases you might want to provision, bespoke storage specific to some other type of application set after the fact. You can also set protection levels, like a snapshot template, nodes, all that other stuff. So we're not going to mess with that too much, but I wanted to show you how you would leverage this if you were kind of doing this like a self-service catalog. So if you were to go in and create an NPOD, first thing you're going to do is, pick the servers that you want to use. We're going to use 4 servers here, and then an application template. So let's say that we were doing like NoSQL and we wanted to do databases, right? And you can pick this guy. It will tell you all the type of servers that are going to be. So 4 servers, 4 SPUs, 40 drives, 8 volumes. And then you would go in and set the networking for the data plane on the cards that you had talked about earlier. And then name it, put it in an NPOD group, like NoSQL databases, for instance, and then go and create the pod. Now, we're not going to do that because we want to show you some of this through a demo, but there you go.
Right. So basically, what you just shown here is quite powerful, right? So if I would compare this with a traditional way I would set up an application cluster, we call it an NPOD. You would have to set up your external storage array, which in and by itself is already a couple of tasks. You would have to set up your fiber channel fabric, your storage fabric, right? You need to install the operating system manually, and then you have to bring all of that together, right? That in and by itself traditionally is already, from an automation standpoint, a lot of steps, right? A lot of steps that you have to code through, that you have to automate and then make work, right? And if that's all infused into this template, right, it's basically a single click of a button, like the self-service characteristic is really shown here. So thanks for that. Mm-hmm. Now, the other aspect of automation is the more obvious one, right? That of using scripts, using software development kits and automation frameworks to achieve your goals. Now, with Nebula, there's a variety of automation options available, using comprehensive SDKs that leverage the single API in the cloud. And I think, Aaron, this is really best described and discussed as part of a demo.
Right. So let's kind of take you through like what this is going to look like, right? So what we've got here is a configuration manifest, which is simply a YAML file that describes the desired state of whatever infrastructure we want to provision in this case. Mm-hmm. This is hosted in a GitLab repository that has webhooks into Jenkins. And so what happens here is that whenever we modify the configuration file in the master branch, or main in this case, that executes a webhook to Jenkins to execute a pipeline. And that pipeline runs an Ansible playbook that does a basic NPOD creation, right? We're going to show that to you here in just a little bit. So when that NPOD is created through the Ansible playbook, it is then pushed up in the Nebula on. We can see all of our servers there, and it leverages the application template that we talked about earlier to make sure that whatever we provisioned has all of the properties for that application stack built as part of the NPOD, so that you don't have to worry about that, right? And it's the same every time. So if we kind of pop over here, let's take a look at GitLab. And what I want to show you here is the basic structure of what's going on. But before I walk through this, I want to go ahead and tell it that, hey, we actually want an NPOD built. So if we look here at this particular file, we can see that NPOD state is set to absent, right? So in our definition of our infrastructure right now, we've said we don't want this to exist. So what we want to do is make it present. And when we do that, we're going to commit to master because you only live once. So here we go.
Right. But I guess, right, in a production environment, you would not commit directly to master. You would use your regular, processes that we use for writing regular code. Like you have a branch, then you make a PR, and then you have a review process, and get it approved and merged.
Absolutely. Do as we do. Do as I say, not as I do. So anyways, now that we've done that, if we kind of come over here to Jenkins, we can see that this pipeline has already been kicked off. And let's take a look at the console output. And if we scroll down here, we can see that it pulled in some variables for us, spit out some of the config that it's going to use, and you can see that the task for creating the NPOD is going to run. So while that's running, let's kind of go back over here and take a look at all the components of the project real quick. So first of all is the Jenkins file. This is pretty simple. It's pulling in some credentials. It's telling us which Git repository to look at. And then it tells it, here's the Ansible playbook that's going to be run with the inventory that it needs to use. So if you've ever used Ansible, you know that you kind of start with an inventory. So if we look there, we're going to use some HPE servers here, and you'll see that there's 4 servers defined, server 05 through 08, as well as some variables for each one of those servers that tell us, what SPUs are in those boxes and so on and so forth. If we go back to the vars thing, which is what we just modified, let's kind of go through that just real quick. So this particular properties file is telling us metadata about the kind of NPOD we want to build. What name it should have, what template to use, what application group it applies to, some networking specific to the cards, so on and so forth. But there's also this volumes file, right? So remember we talked about in that one particular template, there was no additional storage provision, right? So here we can say, hey, we're going to do some higher level automation of this thing. So we don't want to provision any storage during the NPOD creation workflow. We want to have whatever workflow that runs after it is responsible for provisioning the specific stuff that we need. And we can see that there's 3 volumes presented here, that they're all state present. So when this runs, those volumes will all be created. And then let's go back to here and just take a look at the playbooks. And then here's the playbook that actually gets run by the Jenkins pipeline. And you can see it pulls in these 2 vars files and executes the Nebula on Ansible module. This will be available on Ansible Galaxy, so it'll be easy for you guys to download and kick the tires on this once it's released. We then go through and set up some SPU serials and IP addresses that we need for building the NPOD, and then we execute the workflow to create the NPOD. Once that's done, we say, hey, an NPOD's been created, so we're going to need to reboot it. So we mark that flag here, and then we go through and create the volumes and then create the exports, right? So we create the volumes and the exports make them visible to the hosts. And then at the end, we reboot the servers. Because if you imagine you had a server that had no internal storage that it would see, now we've provisioned a boot volume to it. Now we got to reboot it so it knows that it can boot from that disk.
Right.
So if we go back and take a look at the pipeline, we can see that it created the NPOD and now it's rebooting the servers so it can pick those things up. So if we go and take a look at Nebula on and we refresh this, we should see an NPOD. And Shazam, there it is. So we've got our NPOD, with all the stuff that we wanted in it, as well as the volumes. So the boot volumes that they boot from, as well as those 3 volumes that we had just created. Right. And then if we wanted to change those volumes, right, we could go back to that vars file. And then if you wanted another volume, you could simply edit this, mark one of these volumes as not present, and then execute it again. It would remove the volume. Or if you wanted to add a new one, go on and do that. Commit it, boom, you're done.
Right, so I as a developer now, I'm basically filling out this form that you showed earlier in the graphical user interface just with code, right? With the tools that are familiar to me, like Git standard process, right? Jenkins as a CI/CD tool, obviously a standard. So basically I can use the same tools that I'm used to for writing code to also manage my infrastructure. So for me as a developer or in a DevOps team, I can self-service provision my infrastructure because it's all native to me, right?
Absolutely.
Right, and I think this approach to this really nicely demonstrates this approach to cloud-based management because there's a lot of references when you look at cloud provisioning using a similar style of automation, and I think what you also showed is looking at this playbook, there were just a handful of steps in there. And as we established earlier, with traditional infrastructure, that's a long list, a lot of things that can go wrong. So it greatly simplifies, your automation efforts, through this template-based provisioning approach and Ansible. And I think overall, this approach to cloud-based automation, makes it really easy for you to automate your infrastructure, whether it's template-based, whether it's using this self-service provisioning capabilities that we showed earlier in the graphical user interface, and all of it combined. Now, we haven't talked much about it, but for effective on-premises automation, not only a single API in the cloud is required, but also a data plane that supports any application anywhere with better control. Now, there's many reasons why any particular application is using a hypervisor, whether it's using Kubernetes or if it just wants to run bare metal on a server. Now, limiting your infrastructure to just support one type of workload will come with challenges, specifically because it restricts developers and the product teams in terms of their design and an architecture. So in order to react to developers' needs, infrastructure that is hypervisor agnostic, operating system independent is really desirable. And that gives you the freedom of easily shifting services and support your application teams. Now, along the same lines, you want a cost-effective infrastructure that delivers the same data services in different deployment scenarios, whether it's in your core data center or at the edge, where really the size of the infrastructure is only the factor that changes. Now, this is done by having an enterprise data plane embedded into the server, not on the CPU, because that would introduce complexity and unwanted dependencies, not to mention overhead. But this is done by running those services on a PCIe card in the server. And that gives you higher density because you don't have an external storage array and you don't have to compensate for the overhead of CPU and memory that is caused by software-defined storage. And then lastly, full control of the boot device and the separation of data from the operating system is needed. This is what enables customers to quickly alter the personality of servers and application clusters from one to another. This is what enables customers to deploy entire application clusters with the operating system, with the application, and the data volumes in just a few minutes, as we've seen in the demo, right? And this is what enables customers to remotely update clusters without service disruption, because the data plane remains unimpacted when the operating system reboots, when it fails or undergoes any other type of maintenance. So why Nebula on smart infrastructure? Application owners and product teams are now put into the driver's seat and can self-service provision their own infrastructure from basic rack to the full application stack on their own, accelerating time to value through user interface or through code. Massive gains when it comes to operational overhead through zero-touch remote fleet management, AI cloud assistance, and an API-first infrastructure management approach that is delivered as a service. With that, you get cloud-like operations for your on-prem infrastructure at the core and at the edge. By avoiding the expense of external storage arrays and avoiding the restrictions of hyperconverged infrastructure software, you gain significant efficiency and cost improvements, and not to mention the simplicity when it comes to automation. And then lastly, a solution that is operating system and application independent. You protect your investment for today and the future. You gain the ability to automate not just virtualized environments, but containers and also bare metal. So you're prepared for whatever may come in the future. Now, if you can get these benefits for your application workloads in your on-prem infrastructure, you can now start thinking about the cloud as an operating model instead of a destination. And today, Aaron and I just briefly provided an overview of Nebula Smart Infrastructure and the different aspects of automation. There's a lot more detail to share, obviously, so please check out our resources on our website at nebulon.com/resources, our resources on GitHub, and schedule some time with our solution architects who can walk you through all of what we have talked about and more in much greater detail. We can also facilitate remote proof of concepts where you can try out on your own with your own applications. In any case, thank you all for attending and listening, and let's see if we have some time for questions here.
Let's see.
Yeah, there's one. So you mentioned SDKs. What SDKs are available? Right. So I've mentioned it earlier. We have obviously an Ansible module, as you've seen in the demo. We have a Python SDK. We have a .NET SDK written in C#, and we do have a PowerShell module. Now, Aaron, if you can talk a little bit about where I use what of those.
Right. So, just talking about Ansible first, since that's what we just discussed. Ansible is written in Python, right? So the Python SDK is a natural way to interact with that. It's also a Swiss Army knife. So if you've got just general integrations that you want to make, the Python SDK is a great place to start.
Right.
If you are a VMware administrator that's using PowerCLI, then the PowerShell module is kind of where you want to learn, right?
Right, yeah.
And it also takes, that uses the C# SDK that you were talking about. to execute that.
Right. Yeah. So I guess it really depends on in terms of what type of application, what type of infrastructure we want to automate, and we focus on the ones that have like the broadest let's call it support when it comes to community. Like Python is fairly well known, right? So almost anyone can write a bit of Python code. And then, VMware, as you mentioned, there's a strong community around PowerShell. And the whole idea, and that's also the idea why we focus on Ansible so much, is our template-based approach to infrastructure automation, right? That already takes care of so many things that you would otherwise have to automate on your own, like the operating system installation and the mapping of volumes to servers and providing those volumes to servers. That is easily combined with Ansible, right? Ansible is known to be this application configuration, application automation framework. So you can basically automate infrastructure and your application is just one tool, and you don't have to, write your own custom scripts and make use of multiple different tools.
Absolutely.
Right. The next question is here: what are your plans for additional automation features? Actually, that's a good point, right? So we've focused right now on Ansible mostly, and we've talked about the SDKs, but there's basically two players that we are interested in providing automation for initially, specifically orchestration frameworks, right? We have the Ansible module is just about to come out, right? We're in the final stages of polishing it up and publishing it on Ansible Galaxy. But we're also looking into like more infrastructure automation orchestration, right?
Right.
And that would be
Terraform, right?
Terraform, yeah. Where would I use Terraform?
Well, Terraform is great for like building out infrastructure itself, right? So if you're doing like bare metal provisioning and stuff like that, that's where Terraform really shines.
Right. So, and then with Ansible and Terraform, we've seen customers combining those two technologies together to do their end-to-end infrastructure automation. Right?
Yeah.
So,
you start with Terraform, build the infrastructure, use Ansible on top to fine-tune it for what you need.
Right. Where can I find more information about the API? Right. So, the API itself, right? We use a GraphQL API. It's a self-documenting API, but for convenience, we have really published a couple of SDKs, right? That makes it easier to get started because it has like the native primitives of Python and C#, etc. available to you, so you don't have to cast different things and parse various different outputs from an API or do failure handling, right? So, Aaron, why don't you start sharing your screen one more, and I'm sure it's where we find more information about our SDKs.
Right. So if you head on to github.com/Nebula, that should land you here. And underneath the NebPy client, which is the SDK, we open that and we scroll all the way to the bottom down here, you'll see a link to the current version of the documentation. If you open that and go to the API glossary, that's kind of where you can get started on the methods that you can use within the SDK to mutate your infrastructure.
So basically, this is the full details in terms of the API spec, etc. And there's also like examples on how the installation works, right, and how to get started. You're writing your first script, basically.
Right.
Okay. I don't see any more questions, and I think we're out of time here. So again, thank you so much for attending and listening, and hope to see you all in the next time. Thank you so much.
Thank you.